A recurring theme in this Congress has been the major effect that frequencies have on our health. Our next speaker works with multi-allergy prone patients. Because of his research, there is significant data pointing toward the significance of electromagnetic radiations as a source of coherent excitation for a biological system. Dr. Cyril W. Smith is a PhD in physics and is in the Department of Electronic and Electric Engineering at the University of Salford, England. He is the author of numerous articles dealing with the interactions between electromagnetic fields and living systems. I give you Dr. Cyril W. Smith.
Well, thank you very much. And thank you also to Steve and Laverne Ross and the World Research Foundation for inviting me to come and talk with you here. Is this loud enough for the back? Good. Also, I need to acknowledge gratefully more than 13 years of cooperation with an eminent theoretical physicist, Professor Herbert Froelich, and over more than the last 3 years with Drs. Jean Monroe and Ray Choi and Dr. Bill Ray, who've taught me an awful lot about allergies. Now, I'm going to start off with a little bit of basic physics. I hope that you won't all stand up and say, I know this already, but I'm going to just introduce the basic ideas of the interactions with electric and magnetic fields and frequencies. And while this amplifier is oscillating slightly, it's a good example of something that I'll be talking about later on, and that is the resonance and feedback around an amplifier system. So remember when we come to it. Now, a week or so before I left, I had in the mail a Bioelectromagnetic Society newsletter, and I was very pleased to see in there that your National Academy of Sciences, National Research Council Advisory Committee has acknowledged the existence of non-thermal effects of non-ionizing radiation, and although it reserves judgment on the health matters. Looking at things from the other side of the Atlantic, I am very pleased to see that, because you may not realize it, but you were in a catch-22 situation. Now, the living system seems to be making use of the whole of the electromagnetic spectrum for its vital purposes. And just to rather show you, in the words of Moliere's would-be gentleman, that rarely all scientists and biologists have been talking prose all the time and not realizing it, that if we go from ionizing radiation, which is the limit of the concern up here, through ultraviolet, visible infrared, sub-millimeter, millimeter waves, centimeter waves, radio frequency, right down to sound waves, which were discussed earlier, and even lower to geomagnetic fluctuations, you can, in terms of frequency, address yourself to the whole spectrum. You can address it in terms of wavelength. If you're a spectroscopist, you may address it in centimeters to the -1. If you're dealing with quantum events, in terms of electron volts of energy. If you're a chemist of mature years, you will be thinking in terms of kilocalories per mole. Otherwise, you will be thinking in terms of kilojoules per mole. If you're a high or low temperature or plasma physicist, you will be thinking in terms of temperature. And all of those are another way of talking about energy. And as a physicist, the energy would come in quantity called joules, but what is a very similar quantity in communication engineering is the spectral power density, and that is the power in a unit bandwidth, watts per cycle. And so you can see that if you can cut the bandwidth, then you increase the effective power available, which is what is done in a lot of communication systems. And we had a list of frequencies, a list of chemicals in the environment from Dr. Bill Ray earlier on, and I just want to show you this. You won't read the small print, but it lists the allocation of frequency over the electromagnetic spectrum. And just look at this as I roll it past, because it shows you that everything from the audio frequency range right through kilohertz. Yeah, okay. Fine. Thank you. As I roll it past, you can see that from kilohertz, hundreds of kilohertz, megahertz, the whole of the spectrum from the audio frequency range right the way through into the microwave region is allocated. Somebody is using it. Just as you have the 80,000 chemicals around in the environment, you have frequencies which are being used by somebody. There are a few exceptions which are kept quiet for the radio astronomers, but nature is using those. You have formaldehyde, you have hydrogen and hydroxyl lines, water vapor lines, oxygen lines in the environment. And just sitting down here is a little band which is reserved for microwave cookers. It isn't the optimum, but it's historically where they were, and it's very likely they'll stay there. Now, frequencies, waves. We're looking at something that is periodic. It fluctuates in space and in time. If you stand on the cliff tops, you watch the waves coming in. If you take a photograph, you see the waves stretching out to the horizon at one instant of time. If you have a boat moored in one position, it goes up and down in time at one point in space. The waves propagate through space and time with a velocity. And you can specify in terms of the number of cycles in a unit of time or in a unit of distance a frequency. And the frequency, again, has a further bit of physics associated with it, and that is the physics of coherence, because it has to stop and sometime, it has to be started at some time. You haven't an infinity of time available. So the implication of that, which is a perfect sine wave between the time it starts and stops, is that when you look at the spectrum or the bandwidth, there is a limited line width available. The laser makes use of energy pumping to get a very narrow line width, which is why that laser pointer is so effective in comparison to the light from a filament lamp. And in order to communicate with these signals, oscillations, you can impart the information onto it in what is called modulation. And the living system will be using its electrical oscillations for communication purposes, and it will be using some form of modulation. Now, everything that goes on in that plastic bag of salt water or near salt water that forms a living system is very dependent on water. And water right through the microwave region to the infrared is strongly absorbing. Everything that goes on inside you is going on in near darkness, but not quite, because even at the peak of the absorption, the half-value layer for water is still about the dimensions of a biological cell. And so although the interaction is strong, it gets a short distance. And if you want to do a secure communication system, you sit it on an absorption band so you know it's not going to go too far. And a living system has specific means of communicating over long distances by nerve tracks, and the foot is not going to accidentally talk to the head because of anomalous propagation conditions. Now, Dennis was giving us some figures about the power output of the cell, and the living system also functions somewhere near quantum sensitivity. The eye is functioning somewhere between 5 and 14 photons to give a visual sensation. The actual level in the retinal dye is somewhere near 100%, but there are inefficiencies in the system. Photographic emulsions, photocathodes for comparison. Even the phenomenon of microwave hearing, which was shown some years ago to be a thermal effect. When you stand near a radar transmitter, you can hear the pulsations. If you work out the actual thermal levels, you find that the ear is functioning at a quantum level there, and the threshold for that effect is about 3 sound quanta, or 3 phonons per pulse. Now, while I'm discussing quanta, there is another theoretical concept which just mentioned briefly, because I can't go into it in depth at this talk, but not only is energy quantized, just as atoms and molecules come in packets, magnetic fields come in packets. Felix Bloch in Stanford in the 60s did a model-free calculation for this, and as Herbert Froelich has pointed out, that if a system is able to use magnetic flux quanta, then it also has the Josephson effect available to it. Now, in an ordinary physical system, you can only get this effect by going down to liquid helium temperatures. But the living system is not a closed thermodynamic system. It's open, like a radio receiver that uses the batteries for a source of energy. So with an energy going through the system, an open thermodynamic system, it is possible to consider that nature may well be using the quanta of magnetic flux as well. So from the physics point of view, what is the fundamental limit that a biological system can use? Because it looks as if, at least in the eye and the hearing, one has got near quantum sensitive detection. So for purposes of argument, let's say that we take an electric field and a magnetic field, and these calculations give an energy density. If we multiply that by the volume of the sensitive detector and equate that to thermal energy, what we're saying is that if the field can impose an order on the living system which is greater than the thermal diffusion trying to produce disorder, then that ordering will persist. If the, it's another way of saying in engineering terms that you've got a signal-to-noise ratio of unity. Now, the implications of that are that for a 10-micron diameter cell, you've got to get 140 volts per meter, which is a very strong field to get in an electrolytic solution in order to impose an order. But if the whole of a 70-kilogram human can function cooperatively, then you get the sort of sensitivity that has been found for electrically sensitive fish, and the sensitivity which is approached by some of the reacting allergy patients. And in terms of magnetic fields, the biological cell is of the order of magnitude of being sensitive to geomagnetic fields, and a 70-kilogram human potentially could detect extremely small magnetic. If you translate those fields to power densities, you find firstly that the sort of thermal power level that a biological cell could respond to is about the 100 watts per square meter, which is the non-ionizing radiation figure, although there are changes around. And it's about 1/10 of the solar constant. And you know that if you go out into the desert, you don't immediately drop down due to excess radiation. But if you take the figures that Dennis had on his slide for the power output of a cell and the surface area of the cell, then that comes about here. So that the cell itself, on its power output basis, is gained somewhere near a signal-to-noise of unity. And these low-output tumor cells may well be dropping below a signal-to-noise of unity in their power flowing through the cell membrane. And that is where nonlinear effects come in, and you'll find those described in the writings of Professor Froelich. Now, the next bit of basis is that we're dealing with systems that are control systems. They are in homeostatic equilibrium. So if you take a perturbation when the system is under good control, you don't get any response. If you put a static stress onto it, then the same perturbation will give you a large response. And that lack of seeing that is the reason that so many people have had difficulties in finding a biological interaction with electric and magnetic fields. So the sort of protocol that one would recommend is that you use the living system as the sensor for the effect, because apart from one instance, there is not a detector in the armory of physics that can match the living system. And then you need to perturb it in some way and observe the reaction. If the system is under good homeostatic control, you will get a minimal response, in which case you need not to do better statistics, but to produce a steady stress and push it into the side of the response curve. While I'm mentioning statistics, a lot of the work is testing the wrong hypothesis, and I'll show you what I mean with that, because if you have a biphasic response, as a lot of biological things are, the mean is 0. This power cord to the projector, the mean current through that is 0. It's alternating. The projector's a light, there's power going there, but if you do a statistical test on that current, you'll come up with a mean of 0. And there are statistical tests that will look for periodicities and biphasic responses, and you need to use those in a living system. So, firstly then, where does the onset of the phenomenon happen? And then what is the physical implications? Which bits of physics match those onset conditions? Now, this is an example for the mean generation time of E. coli in a magnetic field, and there is a critical onset condition. And the effect itself is about 4%, and you've got to work very hard to get your controls down to 0.5% before you can see it. But if you raise the field strength, if you put your foot on the gas, it doesn't go faster. It gets more complicated. That's the original bit. And this is a periodic with the periodicity corresponding to that onset bit, but the effect is not larger. So if somebody says you get no effect at 10,000 Gauss, therefore you get less than nothing at 1 Gauss, that you're not dealing with a linear system. So stress the system. You feed it the wrong sugar, you use the lac operans system of E. coli, you measure the beta-galactosidase, and you find then, instead of a 4% effect, at 1 magnetic field strength plus or minus 10%, you've got a shut-off of factor of 5. You go, again, it's biphasic, you've got a turn-on here of 2.5. But I was at a meeting only a week or two ago, and people were doing measurements at 1 strength. To get this, you take a magnetic field gradient and you put cuvettes down the whole thing. So it's like a spectrometer with a broad slit. You may not resolve it, but you won't miss it. And if I had taken readings at 1, 2, 3, 4, 5, 6 Gauss, I would have had 1 anomalous point. Only one rogue point. The rest were hiding away. So we're not looking at nature with anything like the necessary degree of precision. Now, you want to look at the people's raw data, and a few years ago, the late Herbert Pohl gave a talk in England, and he showed some raw data. The experiment was one of dielectrophoresis, which is just taking an oscillator, non-uniform field with a couple of metal electrodes, and you collect a Pearl chain of cells on there, just like dust collects around high voltage points. And in his results, he had an anomaly at 2 kilohertz. Now, 2 kilohertz is the proton NMR frequency in the geomagnetic field. And we checked out the results that he showed, and by measuring the dielectrophoretic yield, which is just the length of the Pearl chain in a given time, you find an anomalous condition which goes when you kill the cells. And it is obviously, this has to be magnetic field dependent. So if you change the field, does it shift? And the answer is yes, it does shift. So the basic physics of the resonance, which is merely the proton gyrating in the field, is the same at whatever the field strength is. In the chemistry laboratory and for NMR imaging, our physical detectors are so weak that we have to use very strong fields merely to get a big enough signal. But if nature isn't limited by that, there's no reason why it shouldn't work right down to the geomagnetic field level. And this is an example of a Pearl chain of yeast cells, which is produced by a pair of electrodes here and an electric field, and these Pearl chains are quite stable. But if you adjust the magnetic field near them, this was set just above the Earth's field, if you just raise the field enough, then these Pearl chains break up. And you can only get a force of repulsion in dielectrophoresis if you have a change of dielectric properties of the cell or the suspension. And this effect can be seen in the only commonly available other proton conductor in physics, and that is the glass of a pH meter. And if you measure the capacitance and loss for a pH meter, you find that when you get the proton resonance condition, there's a dip in the dielectric constant, you get less protons available to form dipoles, and you get an increased lattice interaction, which gives you a reduction in the protons available to conduct. And that is quite a sharp phenomenon. It is one of the possible interactions. But it's interesting, just for a minute, to see what you can do with it. And if you grow a soil bacterium under proton NMR conditions for 10 hours, those are the particular conditions. It's usually so sharp that you have to put a slow sweep on the frequency or the magnetic field to make quite sure you're on there. You find what happens is you get the same nutritional conditions, same total cell mass, but you've got twice as many cells of half the size. So the query is the DNA replication being affected? Are the NMR cells ready to divide earlier? Because in the beta-galactosidase experiment, we were perturbing a repressor protein which sits on the DNA, and that comes off in the presence of lactose and transcribes the beta-galactosidase. If you take a live enzyme system, and the one that we looked at for quite a long time was the lysozyme with Micrococcus lysodeicticus, and you run a control and a experimental cuvette, you find that putting the cuvette into a steady magnetic field does nothing, but if you satisfy proton NMR conditions, you get a reaction which stops in its tracks. But you've got to do the right order. If you turn the RF field on, that is, if you do it in this order rather than that order, you lose the effect. This also has implications in the pulsed magnetic field stimulation of bone healing, because if you look at the waveforms that are used, you find you have a rapid rise of magnetic field, which is capable of producing a change of energy population by the betatron particle accelerator effect, as the simplest way of describing it. You change the flux through a precessing proton orbit and you excite. If you then bring the field slowly back to geomagnetic level, but in a time short compared to spin relaxation time, then you have a lot of highly coherent spin echo oscillations which will be telling the surrounding tissue all the biochemical tittle-tattle of the local environment. And as an example of the sort of hierarchical approach that I suggested to trying to prize out of nature how it's doing its physics, this is an example of some work with trying to produce cataracts in bovine eye lenses in vitro. And believe me, we know an awfully large number of ways of failing to produce a cataract with fields. But you can see that if you set up proton magnetic resonance conditions, you get nothing for sodium or phosphorus. If you sweep through the resonance too quickly, you get nothing. But if you satisfy proton resonance conditions on the modulation of the microwaves, you're using the microwaves as a carrier, and you have a very coherent source, and you then modulate that so that the modulation satisfies proton NMR conditions, then over a power density down to sort of 1 to 2 microwatts per square centimeter over 17 hours, you can produce cataracts. If you cut the power density below 0.4 of a microwatt per square centimeter, then you don't get them. But this is just an example of a sort of hierarchical approach that you need to go through some sort of ordering like that to until you've cracked all the variables and you start to get something that's 100% effect. And then, you know, it is much nicer to do statistics on 100% effect. Now, while we were looking at the dielectrophoresis, we had reasons that I can't deal with in detail for expecting that the cells were also emitting radiation. And so the experiment really is to get the cells between a couple of electrodes which are very close together, so that this is probably a Helmholtz depletion region where you can get a good electrical insulation, low conductivity, very highly deionized solution, so you've got to choose what you do it with. But if then you sit and wait with a synchronized cell, so you know when you should get a cell division, and in this case at room temperature we waited about 4 hours, then you may get, coming up out of the noise, a coherent signal which narrows down and then broadens back out again. And this particular one came up in the 7 to 8 megahertz region, and this was the narrowest spectrum we got and were able to record. You're looking here at a spectral line of just above noise level. The output is a few tenths of a microvolt into a spectrum analyzer input, and it is 50 hertz wide. 50 hertz in 8.5 megahertz. It's tens of parts per million in that little plastic bag of water. It knows about frequency to that sort of coherence. And if you do the sum, you find that it has to be coherent, because just filtered random noise would give you of tens of kilohertz, and taking just the number of quanta in that sort of signal gives you about the right sort of quantum bandwidth. Now, what sort of things are we looking at in living cells? You see, this is an electrical engineer's model of a biological cell, as opposed to the biologists and histologists' models of cells. And so we start off at sort of good engineering principle of taking a nice round number. We'll call it a micron in size. And you can measure dielectric properties. Pohl has done this, Pethig has done it. You can measure the total charge you need on the cell to establish the potential, but you can also do the sum about the possible resonances that you can have on the cell membrane, and you can have, for example, transverse acoustic waves, compressional waves in the liquid, which come out at about 10 to the 11 hertz. Those are the ones that Fröhlich picks for purposes of his calculation in his earlier papers. But you can have also electromagnetic waves that come out round about 10 to the 12, 10 to the 13 hertz, depending on the cell size. You can have longitudinal acoustic waves around there. Those come out in round about 100 megahertz. And you can have surface tension waves at an oil-water interface, and those come out a bit lower. Just taking the cell membrane as an oil-water interface, and you have these possible modes. Now, Herb Pohl has confirmed some of those modes for yeast, and the one that I showed you around about 8 megahertz is of particular interest, because Sidney Webb also calculates a frequency around about 8 megahertz from the rate constant of ATP hydrolysis. So the question is the cell, when it needs a lot of energy, calling up its energy supplies by pushing out the right frequency to switch it on? Now, not only do cells emit electromagnetic fields, and there's a big jump now from single cells to lots and lots of cells, humans, but people emit electromagnetic radiation as well. The simplest test of this is to get somebody that is an allergic subject reacting to cuddle a spectrum analyzer with the cheap one with a plastic case running on record with no microphone attached, and there's enough coupling into the amplifier, and you get a complicated spectrum. And this is something that you can observe, but I'll show you another complicated spectrum, and this is a trick. See, that is a similar complicated spectrum, but I know what made that. That spectrum came by putting this into a tape recorder, into a spectrum analyzer. It's an AppleSoft program. Now, the point I want to make is that spectrum analysis is fine, but there is no way of going from the spectrum of this that you just saw to reconstructing that computer program. And if a lot of the electrical information from a living system is in the form of computer-like instructions, you won't read them from the spectrum. You need something like a code-breaking program. Now, not only do people emit in the audio region when they're reacting allergically, But on one occasion, we got an allergic subject into the laboratory in the university, and we did firstly a control. This is me holding the input leads to a spectrum analyzer where you scan from 0 to 2 megahertz. This is the medium wave band radio transmissions inside a building picked up by just holding the input leads. Experiment anybody can do. If the room is not well screened, then you'll pick it up. If the the transistor works inside the room, you're getting that. But superimposed on it, when the subject was holding the input, you've got these spikes. And the level of those was about 800 microvolts, and the skin resistance was about 50K. Now, I know that this sum ignores the reactance, the capacitance of the skin, but I don't know what frequencies necessarily are active. But I do know that a lot of the allergy patients screw up computers. They can type it correctly into the keyboard buffer, they press enter, and they get garbage. And you realize that that signal level is enough to trigger transistor logic. So, you see, we have a class of people who are unwell at certain instants of time, and the illness is a failure of a regulatory system. And Bill Ray has given you some examples of the many chemical and electrical things that perturb the regulatory system. And I merely here want to acknowledge Jean Monroe and Ray Choi, and just point out that what we will be trying to explain this afternoon is how we have begun to apply their Joseph Miller's confrontation neutralization therapy to the treatment of electrical sensitivity. But when diluting allergens or homeopathic potencies, you find very often people are going beyond Avogadro's number. No more chemistry, but there is still physics. There's physics even in a vacuum. And in chemical therapy, Dr. Monroe has gone beyond 300 and had cyclic responses right the way through. Now, I'm going to show one or two examples of the electrical sensitivity, and this is the brief case history as given to me by Dr. Choi, and subject LP had a 17-year-old schoolgirl when tested. She's now in university and is doing very well. She had a allergy history, milk sensitivity, rhinitis, migraine as a teenager, sneezing attacks, medical treatment for blurred vision, eyes okay, and hopefully if the video works this afternoon we'll be able to see some film of this. Unable to walk, medications, brain scan okay, sneezing fits started by fungi and crop spraying near the house, and was sneezing several times a minute, unable to eat or drink. And frequency dropped when sleeping, seen by all these people, reactions on testing, and as Bill Ray would tell you, the reactions are specific to the patient or subject rather than to the physics of the frequency. And then loss of sensation in both lower limbs, no reflexes and so on, challenged with fungi, and these symptoms could be evoked on exposure to electromagnetic fields. And I have one of the tests that we did on this, and we had a sort of general scale of clinical assessment. with mood changes going to high or intoxicated behavior, normal behavior going right down to something approaching or something that was effectively second stage anesthesia. And immediately the oscillator was switched on in the environment. This sort of effect in these sensitive patients is produced by the sort of electric fields that leak out of a computer or television set. You merely have to take an ordinary oscillator out of a teaching laboratory in the university and switch it on in the same room as the patient is. They can tell you what is going on. And you can see here, over quite small changes of frequency, that this, with the dots, is none of them liked the British 50 Hertz power supply frequency, and we terminated this test when the patient returned to normal for the first time, because she was sufficiently sensitive that we didn't want to provoke the reaction any further. And the other patient, you can see, had quite wide swings of mood change, and eventually we stopped that and had to neutralize the patient against chemical drops of antigen because she collapsed into a sort of fetal position and complained that she was having her perfume reaction. They very often describe reactions under electromagnetic stimulus in terms of a beef or a milk reaction that they have experienced from chemical testing. Now, the fact that you can get action at a distance is very important with this from the point of view of the physics of it. Because, firstly, it means that the patients can identify a tube of the allergen when it's handled, when it's brought into the room, and it means, therefore, that a double-blind test with these patients is meaningless because they can break the blind. And if you think that if either a patient or the person administering the test was allergic, and you've got about 15% probability of finding an allergic subject, then 0.15 plus 0.15 is about your 30% placebo effect, which in my opinion is too high to be something by chance. Now, action at a distance. What you can do is put a filter in. You can't match the sensitivity. There's no detector that'll work, but a metal mesh is an electromagnetic filter. In the optical region, molecules behave that way and you get color filters. But in the microwave region, your metal meshes, if the thing is half a wavelength wide, then the waves will pass through it. And so the concept, and remember at the beginning that was oscillating when there weren't enough people in the room to to absorb the energy. If the electromagnetic emission from a reacting allergic subject is stimulating a resonance in that tube, which is then re-radiated back to the patient, and their amplifier system is unstable, and in a biological amplifier you're talking about a gain of 10 to the 9 or 10 to the 10. And anybody who's built electronics amplifiers with that sort of gain has my admiration and gets it stable. So a metal mesh is a good test. And in this particular example, the effect was screened for this patient with solid metal. A centimeter mesh had no effect, so whatever the interaction was, it was shorter than 2 centimeters wavelength. And a mesh of the order of millimeters in size modified it. Now, the glass of the tube, we sent the tube to NPL, our equivalent to your Bureau of Standards, and the glass is transmitting over that spectral range. It's starting to cut off, it's starting to absorb, but it is not impossible that the glass would permit that interaction. So you've got the concept in that particular case of a resonator, and remember that there is a complete duality between chemical structure and frequency. If there wasn't, you wouldn't be able to do chemical analysis by spectroscopy. Just have a look at the Chemical Rubber Company book, and you'll find every bond, chemical bond has its frequency associated with it. And you're putting those together and making molecules. Now, the next subject was the most sensitive we've looked at, and this lady married, main complaint headache, lasts over 22 years, and blocked nose operations. Other symptoms were particular interest, electrical sensitivities, and migraine before storms. And this subject, if I can just show you firstly the results of tests, and you can see why I need the projector. Not only are physical instruments not good enough for talking about nature, but even visual aids are not good enough. We start in this particular test challenging her with something of the order of 400 microvolts per meter. Now, this has to be estimated. I'm working on an instrument that will measure a field strength at a particular frequency in the presence of frequencies in the environment which are much larger than that, and fields are larger at different frequencies. But this patient was more or less immediately in second stage anesthesia. She convulsed around there, slightly better around about here. You can see that's the audio region, and we're right through into the radio frequency region, and not until we got into region 500 megahertz did we affect a neutralization. Now, this particular patient volunteered to be challenged, stimulated electrically. The test for purposes of a demonstration of sufficiently spectacular was to take her away from ordinary electromagnetic environment of the urban surroundings out into the country, and then take her near to overhead power lines where there were no conflicting effects. And if I can have the slides now, please, I'll just run through a brief sequence of slides, please. Right. Firstly, for electrical testing, one just takes a laboratory oscillator and you just trail a wire to the floor, and in the same environment as the patient. It is controlling the environment, it's not applying an electromagnetic signal in any way to them. Now, you can see the sort of sensitivity. This was taken after the patient had been leaning against a pine wood wall, and she'd been reacting to the terpenes. Now, I've put this in because, as you see, Dr. Choi is holding the patient's hand. Now, the sensitivity of such people is far greater than the muscle potentials on your hand, so that you can see that the laying on of hands healing, for example, with such people is not impossible as far as the physics of it is concerned, when you are dealing with a regulatory system which has lost control of an amplifier with a gain of 10 to the 9. You can see now she's just getting hand movement back. But she's now feeding Dr. Choi's baby, and you can see that it's a good example that she has sufficient coordination, and as you know, it isn't an easy job to get them out every time. But we took her in the ambulance, and she was sitting near the window, and the power lines you can see down the road there, it's sort of quite isolated from anywhere else. And because we know what the symptoms will be, loss of limb movement, we took her down the road in a wheelchair. And you can see, firstly, the tendency is to turn over towards the source of the triggering interference that is triggering the reaction. And then you can see now she has gone into spasm. And that was at about 200 meters from those overhead lines. They're about 400 kV lines. When she was in a sensitive condition, obviously, and you have to get her away from all the other power wiring in the house and everything else to see this sort of effect. But then you can see Dr. Choi is again trying to restore the equilibrium. But if you look out of the window, the thing has just gone back under the overhead power lines over the road. And somebody in that condition couldn't safely drive a car. And we have had sort of fathers write about sons who have driven off the road when they have probably been allergic reacting at the time. And this is just the general setup, a laboratory oscillator, and the black is screen cable, the red is a meter of unscreened but insulated wire about a meter away from the subject. And by just going through slowly all the frequencies, eventually you can find a frequency which does neutralize the allergic symptoms. Now this shows the similarity with this patient between you see here I've plotted frequency to log to the base 5 to compare it with dilutions made on a scale of 5, and you can see that the approach of the successive neutralizations to the final neutralizing point follows quite closely the subject's phenol reactions, so you can't, although we've now looked at about 60 of these patients, say that any one frequency is better than another. It's a characteristic of the patient. And these are neutralizing frequencies, and they span really from hertz to gigahertz. And what do you do when you need a microwave frequency and you have to check in the laboratory oscillator that you've borrowed from the university the following Monday? Microwave oscillators are not really suitable things to give to patients anyway, particularly the high voltage valve operated ones. And we remembered, fortunately, that a homeopathic materia medica has electricitas and magnetis and X-ray and ultraviolet in there. So we tried to potentize the water that we knew the patient tolerated, some mineral water, and Dr. Monroe uses this sort of glass evacuated tube and for dilutions, and the question of succussion came up the other day. If you dilute into this with a needle, then the turbulence produced is probably equivalent to succussion, and homeopathic pharmacists say that years ago people did experiment with drops of water, with jets of air to potentize. So a tube containing water, which could be held in the subject's hand, water they did not react to, no clinical effect. You put this same tube, sealed up, into a coil magnetic field at the frequency that neutralizes the subject. And that has the same clinical effect as leaving the oscillator on in the room. And it seems to remember it for weeks or months, usually until the patient has a severe allergic reaction. And I think what is happening is that they are overwriting the water themselves, because reflecting their own emissions back at them isn't very good, like feeding them their own urine. So what can happen in water that is able to produce this sort of effect? Well, this is a little model. If you take the sort of standard water structure and you see what happens when you try to make ice crystals, you can get something and with a little bit of bond bending. But if you, instead you go on and you let the thing take its own way, you've got a solenoid. And the electric and magnetic fields are sufficiently strong. And in fact, the fields, because the distances are so small, the fields are positively enormous. And you can, this is a delay cable. Any electrical engineers here will recognize a helical coaxial delay line, and the outer conductor is not particularly critical, but you can work out a wave velocity. 1 cc of water has enough molecules in it to give you 10 to the 5 seconds of delay if you ordered it all in that way. So there's no problem about how do you get to a low frequency. And you can work out the conditions that a magnetic field will produce enough electric field to produce enough magnetic field the next half cycle, so that if you close the thing up like a toroid, then it should behave very much like a permanent magnet, and once you put the energy into it, it should stay there. Now, apart from clinical effects, what can I offer you? You can just about find something by dielectric measurements, but if you balance a bridge with water in it, you expose it to a magnetic field at exactly 50 kilohertz, then you rebalance the bridge, you find it's gone off balance, 10 hertz either side. I'm waiting till somebody gives me an oscillator that I can reproduce frequencies to parts per million before it's any point in going any further with that one. But anybody else is welcome to have a go. So this really means that one is thinking in terms of what possible effects can you have. Well, there must be some ordering, and this is very diagrammatical because mentally it's very diagrammatical. But remembering that every chemical bond is an electrical oscillator. So if you take a molecule and use that as a template, then this is going to impose some ordering on the water. If you then dilute that beyond Avogadro's number, the fact that you've got clinical effects, so you're trying to find an explanation, suggests that you retain the ordering in the water long after you have passed Avogadro's number, and dilution and succussion is rearranging that ordering that was put into the water before you applied the field. And where else can that happen? Well, most of the cell water, as James Clegg has pointed out, is ordered, and if that ordering is in the form of such a helix, then the charge density on that is enough to give you a fiber optics light pipe which will reflect everything right up into the hundreds of angstroms region on ballpark figures. So is the actin filament the inner conductor? Is the water the outer conductor of a TEM mode transmission line within the cell? Fritz Popp finds photons coming out of cells at certain instants, and those appear to be coherent. The only structure which is the right size to accommodate optical photons is inside the cell. So really my conclusion is as follows, that you can't presume now that the results of an experiment involving a live biological system are independent of the allergic state of the experimenter, that a reacting allergic subject can buck the experiment, and also that you need to monitor and document the electromagnetic history of all the water you use. So you have interactions, electric and magnetic, between people, and it's a pity if mothers and children or husbands and wives electromagnetically trigger allergic reactions, and you also have crowd disorder problems. How much of that is electromagnetic triggering? Plants and animals and water. So some people can grow tissue cultures, or as you say in gardening, some gardeners have green fingers. Thank you very much.